Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien. Welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
The International Space Station orbits the Earth every 90 minutes and will provide an orbital laboratory in a reduced gravity environment for long-term research. This microgravity environment gives researchers an opportunity to study the fundamental states of matter, solids, liquids, and gases, and the forces that affect them.
A unique facility at NASA Glenn is able to conduct microgravity research here on Earth. NASA researchers can study how the lack of gravity will affect the experiments before they are brought into space. Jennifer Pulley takes us inside NASA Glenn's 2.2-second drop tower.
By now, you've all seen astronauts and objects floating around inside an orbiting spacecraft, seemingly free of Earth's gravitational field. But these images are misleading. In fact, these objects are actually not floating, but in a state of continuous freefall. Any object in freefall experiences microgravity, or weightlessness, which occurs when the object falls towards the Earth. Before NASA researchers send experiments on board shuttle missions or to the International Space Station, they often test them here on Earth. But how do you replicate microgravity here on Earth? NASA Glenn has been conducting microgravity experiments since the 1960s in drop towers like this. These facilities rely on free fall of the experiment to produce a microgravity environment. Here, NASA can test experiments in a reduced gravity environment, similar to orbiting in space.
The 2.2-second drop tower is one of two microgravity facilities here at the Glenn Research Center. This facility is just under 80 feet tall. We can drop experiments in this facility weighing up to 350 pounds. They'll reach a terminal velocity of almost 50 miles per hour just before they hit the airbag at the bottom of the tower. We create microgravity for 2.2 seconds here.
You said microgravity. Do you mean weightlessness?
Yes, that's exactly right. Microgravity is weightlessness. Astronauts experience that in orbit all the time. But we need to create that down here on the Earth, and we can do that here in the 2.2-second drop tower.
This is how a drop tower experiment works. Researchers place their experiments inside an aluminum frame, also called a rig. Experiment rigs are then placed inside a drag shield, but are not attached to it. Once assembled, the experiment package is lifted to the top of the tower, then released. When the experiment is dropped, it experiences microgravity, or zero-G, for 2.2 seconds. The drag shield protects the experiment from aerodynamic drag during the drop, which allows the experiment rig to fall freely a distance of 7.5 inches. The experiment experiences weightlessness, similar to what would be expected in space.
Here in the drop tower, what happens is the experiment falls through the tower inside the drag shield. The drag shield is being slowed down by the aerodynamic drag as it approaches 50 miles an hour as it nears the bottom of the tower. The experiment inside, however, is falling through 7.5 inches inside the drag shield and is unaware of the aerodynamic drag that's occurring around it. There's three kinds of microgravity experiments we perform. Most of our work is centered on combustion. All the experiments are basically the same internally. There's a power system, there's a computer system on board to control the experiment as it falls through the tower. There's a diagnostic system on board which takes the imaging or the pressure or temperature data from the experiment as it falls. And this is the experiment itself, the thing that's actually burning or the liquid that's moving around inside the experiment. Now we get all this ready, raise the experiment to the top of the tower that we have now, and we close it up, package it up, do a countdown.
Stand by for go. 3, 2, 1.
And as the experiment falls through the tower, it's in microgravity. That's when the experiment runs.
Why do we conduct microgravity experiments here on Earth when we can easily conduct them in space?
Well, actually, to conduct them in space is quite expensive. The numbers I've heard is about $10,000 per pound just to lift the experiment into space. Not to mention the cost of having the astronaut operate the experiment while it's up there. Now, here in the drop tower, it's quite a bit less expensive to do that. And if we make a mistake, we can go back and run the experiment again quite rapidly. Our researchers set up the parameters for the experiments that do go up to space, right here in the drop tower.
So how do the combustion experiments that you conduct here at this facility in microgravity affect me, the general public?
Well, the whole idea here is to understand combustion at the fundamental level. Once we understand that, we can go out and make cleaner burning engines, cleaner burning power plants, which means less pollution in the air. So we're less fuel dependent and we have a cleaner environment.
The 2.2-second drop tower was originally built in 1948 to house a distillation tower for making jet fuel. In the mid-1960s, the need to perform reduced gravity research in support of the space program saved the facility from being torn down. Now, coming up, we'll see how playing video games can help people overcome attention deficit hyperactivity disorder. But first, did you know NASA uses a specially adapted plane nicknamed the Vomit Comet that creates microgravity here on Earth? When the plane reaches the top of a parabolic trajectory, the occupants temporarily become weightless, experiencing what it is like to fly in space.